Ayun. So we're back on track. Anyway, so what am I saying is previous meetings were focusing on the recovery and extracting metals. Now we're moving on to polymers, specifically synthesizing polymers. But before we go further with the different types of polymerization, let's refresh some basic terminologies on polymers. Okay, so this should be quick lang. Yeah, so when we say polymer, it's actually based from two Greek words. So poly means polu, so yon, that means many, and then from meros means part. So if you're going to combine those two Greek words, it means polymer is many parts. Ayan. So many parts siya kasi if you're going to look at the structure, repeating lang talaga yung certain part doon. Nire-repeat lang siya hanggang makabuo ka ng tinatawag na macromolecule. Itong macromolecule, it's another term for polymers. So kapag may narinig kayo about macromolecule, it's just polymers. Gets? So a better definition of polymer is it's a large molecule made up of small repeating units. So what is a repeating unit? So a repeating unit, that's just a portion of your polymer that keeps on repeating until makabuo ka ng polymer. So for example, household pipe. So yung household pipe, it is a polymer with a texture of this. Ayan. So kung papansinin nyo, sige, this polymer is called polyvinyl chloride or PVC. And kung papansinin nyo to, ayan, di ba paulit-ulit lang siya? Yung part na paulit-ulit, ito, yan yung tinatawag na repeating unit. Okay? Gets? Claro? Ayan. So another example, given a plastic bottle. So this plastic bottle has a polymer, has a chemical structure na ito. And this chemical structure, this polymeric chemical structure is what you call polyethylene terephthalate or PET. So ito yung mga PET bottles. Ito yung mga nakikita nyo pag bibili kayo ng calamansi juice, Coke bottles, etc. PET. So ano yung umuulit-ulit dito? So kung papansinin nyo, ito yon. So since siya yung umuulit until you complete a complete set of polymer, yun yung tawag na repeating unit. Okay? Gets naman to? Gets na? Alam na kung ano yung repeating unit. Ayun. So ngayon, ano tong hina-highlight ko? Ayan, yung green at saka yung violet. Yung tawag dito ay structural units. Ayan, which came from ethylene glycol. So yung green, ano yan? Yung green, so that came from ethylene glycol. Tapos yung violet, that came from terephthalic acid. So basically, nung nag-react yung ethylene glycol at saka terephthalic acid, nung nag-react sila, yung contributing chemical structure na yon para makabuo ka ng repeating unit, yun yung tinatawag na structural unit. Gets? Naklaro ba yun or do I need to repeat myself? Okay lang naman. Gets, ah? So, ayun. Yan yung structural unit. So, a better definition of a structural unit, it is a residue of your reacting molecule to produce a repeating unit. Okay? Tapos, itong reacting molecule, sige. Basically, meron kang reacting molecule, meron kang structural unit, tapos kapag nag-combine yung structural unit, meron kang repeating unit. And kapag nag-repeat yung repeating unit, doon ka na makakabuo ng polymers. Okay? So basically, you can have many structural units para makabuo ng repeating unit. And it is based, so paano saan nagbe-base kung ilang structural units yung kailangan para makuha ng repeating unit. Actually, nagbe-base siya kung ilan yung kailangan na reacting molecule para makabuo ng polymer. So for example, in this polymer, PET, para makabuo ka ng PET, kailangan mo ng ethylene glycol at saka terephthalic acid. Since you need 2, so you expect na kailangan mo din ng 2 structural units para makabuo ng repeating unit. Gets? Ayun. And this reacting molecule na sinasabi ko, yung tawag dyan in terms of sa polymer technology o polymer science, yung tawag dito ay ang daming sinasabi. Yung tawag dyan ay monomer. Okay? Monomer. So, yung monomer mo, ethylene glycol at saka terephthalic acid. So, what is a monomer? It's just a molecule that reacts with each other to form structural units, and these structural units will combine to form a repeating unit. So, in summary, ito yung hierarchical organization ng polymer terminologies. Ayan. Monomer, structural unit, repeating unit, then you will have a polymer. Gets? How about yung iba? Any questions with this refresher? Wag yung, ito ha, this is parang, dito parati nagkakamali yung mga students sa repeating unit at saka structural units. So now, I want to know if klaro naman yung definition ng dalawa. Kasi, you know, the next MatE subjects, ayokong biglang, hala, parehas lang yung dalawa. Hindi. Okay? Gets ba yun? Okay. So ngayon, di ba? Wait, natawa ko lang. Di ba, may repeating unit na, tapos yung repeating unit, inuulit-ulit mo lang siya, kina-copy and paste, para makabuo ng polymer. Pero, there are times, there are times na yung pagka-copy-paste mo ng repeating unit ay hindi enough para makabuo or hindi enough para makabuo ng big molecule. Okay? So, in other words, monomers react in such a way na few lang yung repeating units that are linked together. And kapag ganon, kapag onti lang yung nagka-copy-paste na repeating units, ang resulta niya sa chained molecule na may few repeating units ay oligomer. Okay? Klaro? Gets ba yun? So, oligomer, galing din siya sa Greek word na oligos, few, and meros, so few parts. And again, kapag oligomer, you expect that its properties is so insignificant compared to the expected properties ng polymer. Okay? So, pag nakakuha ka ng oligomer after synthesis, ay, umulit ka na lang dahil. Kasi, sobrang baba ng properties. Ayan, to have a comparison between oligomer and polymer, ayan lang yan. Repeating units, few. Polymer, many. Properties for practical use, insignificant yung oligomer, significant yung polymer. So, maraming nagtatanong. Actually, this slide, galing siya sa MatE 131. So, that's an elective sa MatE. So, sa students na yun, maraming nagtatanong kung is there a standard to know kung ano yung oligomer at saka polymer? In other words, is there a standard number of repeating units to know kung oligomer siya or polymer? Actually, walang standard unit for that. And yung para ma-distinct lang kung oligomer siya or polymer ay nagbe-base tayo sa property values. So, kunwari, you expect na yung polymer na to ay ito yung property values niya. Kapag hindi yan na-reach to, automatically, dinidescribe na siya as oligomer. Okay? Gets? Ayun. So, okay na yan. So, ayan, na-distinct na natin lahat ng terms. So, actually, ano to? May natanong. Oh, so ma'am, oligomers can still form bulk materials? Good question. Yes and no. So some oligomers can still form bulk materials, but if you're going to touch it, it's sort of parang soft compared doon sa polymer mo. Okay? And sometimes hindi na siya nag-form into a solid material. Minsan viscous siya. Sobrang viscous niya na hindi talaga siya solid thing. Did I answer your question, Kirk? Ayun. Okay. So, going back, yung reaction to form polymer from monomer. So, actually, reaction ng monomer to oligomer or polymer, yung tawag doon ay polymerization. Okay? So, yan. Reaction ng monomer to make a polymer or oligomer, tawag doon ay polymerization. Gets? Ayun. So, ito, quick test yourself lang para lang matest ko kung naintindihan niyo yung mga pinagsasabi ko. So, given the polymerization below, identify the repeating unit, structural unit, and monomer. So, ano to? Itong dalawa. Ano to? Is it a monomer, structural unit, or repeating unit? Oh, yung iba. Yes, monomers siya. Correct. Monomers siya. Kapag nag-react itong 1,6-hexadiamine at saka adipic acid, ang mangyayari sa kanya ay makakabuo siya ng, teka lang, let me just annotate this thing. Why is it not working? Ayan. So kapag nag-react yung hexadiamine at saka adipic acid, kanari, hexadiamine, mawawalan siya ng H. Ayan. So ano to? Ano to? Ito. Ayan. Ano yan? Tapos similar with adipic acid, pag nag-react yung adipic acid sa hexadiamine, mawawala yung OH niya, yung hydroxyl groups, ito na lang yung mabubuo. So ano itong dalawang to? Correct. Structural units. So kapag nag-combine itong dalawang structural unit, anong tawag dito? Ito. Itong malaki. Repeating unit. Good job. And if ika-copy paste natin yung repeating unit, ano yung kabuuan? Polymer. Ayun. Tapos yung polymer pala na ito, yung tawag dito ay nylon 66. Yun lang. Thank you. Here all drawings. Yan. So, in summary, ito lang yung sagot. Nandun yun sa module na binigay ko. Okay, so, muna tayo sa terminologies. Punta na tayo sa polymerization, which should be our focus sa this week, this meeting until next week. So, polymerization, better definition, it's a sequential reactions of monomers, sometimes oligomers, to form a polymer chain or an oligomeric chain. And there are 3 types of polymerization. These are chain growth, step growth, and copolymerization. And what is chain growth? So chain growth, it is just a polymer that is synthesized via a series of chain reactions. So when you say chain reactions, ayan, ito yung literal na kapag nag-react yung monomers, nagka-copy-paste lang siya. Okay? So, example, formation ng polyethylene. So yung polyethylene, so this is ethylene, ethylene. So kapag nag-meet sila, ang mangyayari ay yan, react lang agad. Okay, may repeating unit ka na agad. Tapos kapag may na-meet ka ulit na another ethylene monomer, yan. Yan, para siyang domino effect. Yung chain growth. Pag may nakita siyang monomer, react lang agad, combine. Kaya siya chain reactions, and so forth. Ayan. And it will continue to form a polymer as long as you have monomers or reagents doon sa beaker mo and so forth. Okay? Gets? Chain reactions lang siya, parang domino effect. So, ano yung mga monomers na nag-undergo ng chain growth polymerization? So, ito yung vinyl monomers. So, when you say vinyl, these are just small molecules with one pair of double bonded carbons. So, ito yung mga common vinyl monomers. Yan. Ethylene, propylene, styrene, nitrile, vinyl chloride, acrylic acid. Ito, tetrafluoroethylene, methyl methacrylate, and isoprene. Kung magme-memorize kayo, sige, okay lang. Pero ito yung kailangan nyo lang isa ulo. Kapag nakita nyo tong mga vinyl monomers, automatically, chain growth yan, yung polymerization. Okay? Ayan, example, ethylene. Actually, yung ethylene, pag nag-polymerize, makakabuo siya ng polyethylene. So, ano kaya yung example ng polyethylene? Can you give me an example na ginagamit natin sa everyday use? Example ng polyethylene. Oh, may nagsagot dito na bottles. Actually, kapag ethylene, yung yung question ko dito is, what if ethylene lang at saka ethylene? Okay? Vinyl monomers to vinyl monomers. Hindi pwede PET. Okay? Hindi bottles. Kasi dapat ang polymer dito ay polyethylene, hindi polyethylene terephthalate. That's another reaction. Ayun, correct. May nagsabi ito, high and low. Yes, ito yung HDPE at saka LDPE, yung mga plastic bags natin. Yon, that's an example of polyethylene. Ethylene monomers na nag-react using chain growth polymerization. Okay. And the reason why, bakit hindi PET, kasi di ba yung example kanina sa polyethylene terephthalate, ito yon. Ulit tayo doon. Ayan. Ito yun. Ito yung monomers ng polyethylene terephthalate, PET. Ethylene glycol at saka terephthalic acid. Ang tanong, are they vinyl monomers? Di ba yung vinyl monomers, it should have one pair of double bonded carbons. Diba? Nagets na ba? Nagbo-brew na ba yung knowledge? Okay? Kaya yung PET, hindi siya nabuo dahil sa chain growth. Okay? Iba siya. Basta. Okay? Kaya ko parang pagtingnan nyo, itong itong plastic ba na to? Nag-undergo kaya siya ng chain growth? tingnan nyo kung ano yung monomers. Kapag hindi siya vinyl, or mamaya diene, then hindi yan chain growth. Okay? Gets? Ay, step growth na. Gets naman yon? Okay. So aside from vinyl monomers, dienes also undergo chain growth. So yung diene naman, 2 double bonded carbons ang meron siya. So ito, example ng diene yan. Actually, yung rubber, galing siyang diene. So rubber came, ano siya, chain growth polymerization. Okay? So, huwag kakalimutan, kapag gusto nyo malaman kung yung polymer ay nag-undergo ng chain growth, check nyo yung monomers niya. If vinyl monomers siya or diene. Pag check, then automatically chain growth yun. Okay? Gets na ba? Na-gets na. Okay, another good question. Keep it brewing, guys. Kailangan po ba both monomers are either vinyl or diene? Yes. Kapag vinyl monomer, dapat vinyl monomer din. Okay? Chain growth. Diene, diene. Okay? Okay? That's ba yun? Yung iba. Ano pa tanong? Dali. Actually, na-miss ko lang magturo ng MatE 131. Hindi ako nagturo ngayon ng MatE 131 kasi sa curricular matters. Kailangan siyang ayusin. I-redefine. Bakit po need na same? Another good question. Bakit need siyang same? Meron tayong tinatawag na latent functionality at saka nature of monomers. Malalaman natin yan sa MatE 131. Okay, so kung next sem, diyan ba si Sir Jeff? Kung next sem may MatE 131, enroll kayo doon. Ayun. Pero the reason bakit siya needs same, kasi meron tayong hinahabol na latent functionality, yan, number 1, at saka yung nature ng monomers. Kasi kapag hindi swak yung nature, yung dalawang yon, hindi ka makakabuo ng expected polymer mo. Okay. Gets? Tapos ito pala, when I say nature ng monomer, I'm saying vinyl. So kunwari, ethylene. Pwede naman yung ethylene mag-react with another vinyl monomer na hindi ethylene. You can still make a polymer. Kunwari, polyethylene, pwede yon. Polybutylene, pwede yon. Did I answer your question? Yung kanina nagtanong. Mary Ning. Ayun. Oh, may tanong. Ma'am, yung... Good question. May nagtanong. Ma'am, yung visualization ko ng chain growth, parang one long polymer lang yung nabubuo. Ganun rin po ba in real life? Oh. Or compared to step growth, mas madami lang yung super long polymers. Actually, in terms of chain length or polymeric chain length, parehas lang naman yung chain growth at saka step growth. Yung difference lang nung dalawa is that yung chain growth, hindi siya, paano ba? Di ba may tatawag tayong yung organic chemistry na functional groups? Do you remember? Yun. Yung organic functional groups. Yung mga ketone, yung mga ganon. Yun. Yung chain growth, wala siyang paki dun. Okay? Kung ano yung functional groups mo. Doon lang talaga siya. Pag nakikita siyang double bonded carbon, okay na yun. Makakabuo kayo ng polymer. Yung step growth, which is next, yung next, kailangan masatisfy yung type ng functional groups, organic functional groups para doon sa binubuo mong polymer. Okay? So yun yung difference niya. Tapos yung chain growth, makakabuo ka lang ng isang malaking polymer. Okay? Wala siyang add-ons na parang polymer plus water. Parating ano siya, pure dapat lang siya. Yung step growth, pwedeng ganon, pero minsan meron siyang add-on na mga small molecules such as water and HCl and others. Did I answer your question? Ayun. Ayan, so to further know yung step growth polymerizations. Ayan. Know na step polymerization. So, di ba kanina nag-present ako ng chain growth? So, ano yung mga monomers na mag-chain growth. Pag wala doon, step growth na yon. Okay? So, yun. Stepwise growth of a polymer chain by coupling reactions between any two non-vinyl multifunctional monomers. And that's step growth. So, for example, ito na. Ayan, hexadiamine plus adipic acid. So, kung makikita nyo, ini-emphasize ko yung functional groups sa end. And kailangan to kasi kapag sabi natin yung adipic acid, isa lang yung carboxylic acid niya. Tapos, ayun, hindi siya makakabuo ng polymer. Okay? So, for at least two monomers to undergo step growth polymerization, kailangan yung dalawang monomers na yon should have at least two functional groups. Okay? And when I say functional groups, eto yon. Okay. Gets? Oh, good question. Another good question. Kailangan din ba, ma'am, nasa magkabilang end yung functional groups? Yes. It's the reason to that is based on reactivity nung molecule mo. You can think of it as if you have a molecule, tapos sabihin natin yung functional group mo na kinoconsider mo ay nasa gitna. Actually, stable na siya dun eh. Yung mas unstable is yung mga kalawit. Yon. So dapat, if you're going to undergo polymerization, tingnan mo yung functional groups doon sa end. Okay? Did I answer your question? Okay. So lastly, we have copolymerization. And copolymerization actually, ayan, it's the formation of a copolymer. So when you say copolymer, that's a polymer with more than one type of repeating unit. Tapos there are different types of copolymer depende sa arrangement ng repeating units mo. So yan. Yan, pinapakita ko lang sa'yo. I-discuss natin to further sa next lessons. Tapos, itong copolymerization, it can undergo either, it can undergo step growth. Ayan, depende. Basta, para malaman mo lang na it is undergoing copolymerization, dapat yung monomers na nire-react mo doon should produce different types of repeating units. Okay, so ma'am, naguguluhan na ako. Okay lang yan. I-discuss natin yan later parts para mas makita nyo. Mas maraming examples sa next slides. Okay, gets? And the reason pala we're doing copolymerization kasi kanare, you have a certain application. There are times na hindi talaga sumaswak yung polymer lang. Kailangan mo siyang i-copolymerize with another repeating unit. Ayun, kaya tayo nagko-copolymerize. Ma-achieve lang yung certain properties for that application. Okay. Okay na yun. Ayan. Sige, step growth na tayo. Ay. Ayan. So yung first natin i-discuss ay step growth polymerization out of those 30 types. So ang gagawin lang natin ay define, ba't di nagpumagalan? To define step growth polymerization and understand the basic mechanism of it. Tapos yung mga different synthesis techniques for the step polymerization. So yung step polymerization or step growth polymerization, it has two subtypes. Ito yung polycondensation at saka polyaddition. So ano yung polycondensation? So yung polycondensation, if you react monomers, meron kang byproduct na water, alcohol, or acid. So for example, if we're going to produce yung PET bottles natin, you need these two monomers, ethylene glycol at saka terephthalic acid. And if you check yung type ng monomer, both are not vinyl monomers, both are also not diene monomers. So automatically, alam mo na, step growth to. And if you will check yung mga functional groups na and functional groups, makikita mo na OH. Kasi ito carboxylic acid. If you're going to react carboxylic acid with hydroxyl, ang mangyayari ay magkakaroon ka ng byproduct na water. Okay? So parang isipin nyo, ma'am, how will I know na it's water without memorizing? Okay. If you know the formula of polyethylene terephthalate, tingnan nyo to. Tingnan nyo to. Pag nag-combine yung ethylene glycol at saka terephthalic acid, ang matitira ay ito, C double bond O at saka yung O. So ano yung matitira? Di ba yung H dito at saka yung OH dito? So pag kinombine mo yun, edi H2O. Klaro? And actually, kapag ganon, carboxylic acid at saka OH, automatically, matatanggal talaga dyan ay, ayan, yung mga OH at saka H to form H2O. Okay. Gets. Ayan. And then, we have another subtype, that's polyaddition. So, yung polyaddition naman, that's step growth without forming byproducts. Yes, example. Ayan, diisocyanate at saka polyol. So, obviously, hindi siya vinyl, hindi siya diene. So, pag nag-react sila, ayan, pansinin yung functional groups. Ayan, makakabuo ka ng polyurethane. So, makikita nyo lahat ng molecule dyan, lahat ng atoms ay gamit sa polyurethane. Okay. Ayan. So, cheat sheet. Para meron kayong basehan. Wait lang. Ano ba to? Polyaddition ba to? Polycondensation? What's up? Ayan. So, what types of monomer undergo step growth polymerization? Alam mo na yan? Ito yan. Ito yung sasabi ko. So, meron tayong cheat sheet na ganito. So, if you have OH and COOH, ito lang yung mabubuo. So, kung papansinin nyo to, at saka yung functional groups, may nawala. So meaning yan, that's polycondensation. Okay? Gets ba yun? Ayan. So another thing is polyurethane. So makikita nyo, para makabuo ng polyurethane, dapat may functional groups ka na OH at saka NCO. So titingnan nyo yung OH at saka NCO. Lahat siya nandito. Since lahat to nandito sa characteristic interunit linkage, and that's polyaddition. Ay pala, nakalimutan ko. Itong characteristic interunit linkage, ito yon. Ito yan. Titingnan nyo lang. Yung characteristic interunit linkage, that's the middle part ng repeating unit mo. Kung saan nag-link yung dalawang structural units mo. Okay? Gets ba yun? Klaro ba? How about others? Oh my God. Inirapan ako ni Chelsea. Charot. Ayan o, nangiirap si sis. Ayan ha, huwag kakalimutan para malaman mo yung polycondensation or polyaddition. Check mo lang. Ito na yung cheat sheet mo, sis. Gamitin mo na yan. So pag OH, yan. Ayan, nag-sorry siya. As you should. Charot. Okay lang. Go lang. Ayan. Okay, gets ba yun? Gets na? Do we feel the ano na, we can ano na, differentiate polycondensation, polyaddition? Okay. So conditions for achieving high molecular weight polymers. Okay. Actually, this is sort of a common sense. So if you want to achieve a high molecular weight polymer, so when I say high molecular weight polymers, so given a polymer, dapat makabuo ka ng malaking chain length, mahabang chain length, maraming copy-paste na walang interruptions. Okay, so to achieve that, you need high purity monomers. Okay, so kapag may high purity monomers ka, there's a high possibility that you have clean reactions. So when I say clean reaction, no side reactions. And then high conversion. So when I say high conversion, lahat ng monomers mo or more than 98% ng monomers mo, kasi monomers have functional groups, have formed or have reacted such that makabuo ka nung structural units para mag-link sila together. Okay? Gets ba yun? Itong tatlo, yung kailangan for step group. How about others? Ano, podcast? Ayan, tama. Okay, so okay na. Nag-gets na natin yung mechanism at saka yung paano na yung mechanism at saka ano yung mga types of monomers for step growth. Ngayon, punta tayo sa different techniques for step growth polymerization. So we have two. Actually, there are many, pero for since 165, basic synthesis lang naman yung kailangan nyo, ito muna. So you have interfacial and solution. Pero regardless of the type of technique, mapa-interfacial siya or solution, yung catalyst, monomer, polymer mo dito, you expect them to be insoluble to each other. Okay? So kapag ganari, naglagay ka ng catalyst at ito yung reactor mo. O naglagay ka ng catalyst at saka monomer, insoluble sila with each other. But they're going to react. It's just that they are insoluble with each other. Ayan. Tapos kapag nagbuo na yung polymer, you also expect na yung polymer ay insoluble sa dalawang components mo. Okay? Gets? So kaya magtatanong kayo, ma'am, paano sila nagre-react kung insoluble sila with each other? Lalo na yung catalyst at saka monomer. May tinatawag tayo na solvent. Okay? So yung solvent, yung parang ano nila, ano ba? Tawag siya, common friend. Okay? Gets? Okay, pakialala nito ha. Okay, interfacial polymerization. So this is, well, in my opinion, if you care about my opinion, interfacial polymerization, this is the most fun step growth polymerization technique. And you'll know why. So kapag interfacial polymerization, you are reacting to a pair of immiscible liquid. So may aqueous phase ka at saka organic phase. Tapos each phase, nandito yung monomer mo. Okay? Tapos, yung gitna niyan, diyan, nabubuo yung polymer mo. Okay? So again, yung interfacial polymerization, meron kang dalawang immiscible liquid. Aqueous at saka organic. Tapos each phase niyan may monomer. Tapos sa gitna sila nag-react. Okay? So yung sa gitna sila nag-react, nandyan yung polymer mabubuo. So sa aqueous phase, usually yung nandito ay diamine, diol, active hydrogen compounds, mga monomers na may diamine. Sa aqueous phase, nandito yung mga monomers na usually merong diamine, diol, active hydrogen compounds. Sa organic phase, usually may acid chloride. Okay? So example niyan, ito. Kaya ba?
Interfacial polymerization.
Walang sound. Ba't naman?
Interfacial polymerization is a unique type of step growth polymerization in which polymer is formed at the interface of two immiscible phases. In this example, hexamethylene diamine is dissolved in water and makes up the bottom layer. The top layer is composed of sebaceous chloride dissolved in hexanes. At the interface of the two phases, monomers react, forming the polymer nylon 610. By carefully removing the nylon from the interface, polymer will continuously form until either monomer is depleted. Interfacial polymerization is a unique type of step growth polymerization as it allows for the formation of high molecular weight polymers without the need for equal molar amounts of each monomer. It can also be performed at ambient conditions. Thanks for watching.
Ayan, thanks for watching daw. Actually, yung interfacial polymerization, maraming nylon types. I mean, when you say interfacial polymerization, yung una talagang tumatatak sa isip ng mga polymer technologists, polymer scientists, polymer engineers ay yung polymerization to form nylon. Okay? Kasi yung nylon, marami siyang types. Okay? Malalaman nyo to sa MatE 131, sa elective nyo. Okay? Marami siyang type. Kanina, di ba, nylon 66. Ito, actually, this is nylon 610. Okay? Ayan. Yun. So, di ba, di ba, given this example, di ba, dalawa yung phases natin. May aqueous, tapos organic sa baba. Sa tingin nyo, given these monomers, saan dito sa dalawa yung nasa aqueous phase? Hexamethylene diamine or itong sebacoyl chloride? Yes! Oh my God, they're listening. So diamine. Hexamethylene diamine yung nasa aqueous phase. So paano nila nalaman? Are they smart? No, sinabi ko lang dito. Okay, ito siya. Okay, gets? Ayan. So, yung isa, malamang nasa organic phase. Okay? Klaro? Okay. So, again, pag minarig kayo, nylon. Sure na yan, interfacial. Kahit anong type yan. Most sa kanila ay interfacial. Okay. Ayan. So, ito lang pinapakita ko. So, in a more schematic diagram version, ito lang siya. Ayan. So, yung rate of reaction sa interfacial polymerization is controlled by the rate of monomer diffusion to the interface. Ayan. And then stoichiometric quantities of reactants not needed to start the reaction. And reactions are irreversible for interfacial polymerization. Okay, so Mama, how can you say, do you have proof kung paano to, itong tatlo, rate of reactions, control, ganyan. Actually, sa MatE 131 siya di-discuss, yung kinetics. Pero for MatE 165, you just need to understand or to know na ito yung mga kinetics behavior ng interfacial polymerization. Okay? Gets? Claro? Okay. So advantages of interfacial polymerization. So number one, although high conversion is needed, in general polymerization step growth, pero sa interfacial, hindi siya ganon ka-importante to produce high molecular weight polymers. Number two, kagaya nga sa sinabi sa video kanina, it can be performed under normal conditions. And number three, yung resulting polymer, pwede na siyang ready to use agad. Okay. Ayun. Sorry, tumitingin ako sa paligid kasi may renovation na naganap sa faculty. Okay. So forgive me. Parang sige, okay na ba? Okay. Last, solution polymerization. So solution polymerization, yung reactant, same lang siya sa interfacial polymerization. Tapos, all reactants are dissolved in an inert solvent. A solvent can also facilitate the reaction, and it can be an acid receptor. So, kung compare natin yung interfacial at saka solution, yung interfacial, it doesn't need a solvent because yung reaction niya, nakadepende siya doon sa rate of diffusion, doon sa interface ng dalawang phases. Yung solution polymerization, you need a solvent. And most of the time, yung solvent na yun should be an acid acceptor. Okay? And the reason for that, but kailangan ng solvent ay na acid receptor ay ito. Example ito. Formation of polycarbonate. Kapag nag-form ka ng polycarbonate, meron kang acid na nare-release. Yung solvent mo, which is this, ito, pyridine with CH2Cl2 solution. Itong solvent na to, actually acid acceptor siya. Acid acceptor siya dahil sa pyridine or pyridine. So, since HCl scavenger siya, kinukuha lang niya to such that ang magagawa mo, ito, ay polycarbonate na. Pure polycarbonate. Natanggal niya yung byproducts. Okay, nagets ba yung reason bakit kailangan ng solvent na acid acceptor for solution polymerization? How about others? Ayun. Yun, nagets ba yung difference ng interfacial at saka solution? Again, interfacial, it doesn't need a solvent. Yes, they are immiscible, but you have an interface na kung saan nag-react doon yung dalawang monomers. And the rate of reaction depends actually to the rate of diffusion ng monomers mo doon sa interface. On the other hand, solution polymerization, you need a solvent, and the purpose of the solvent is para matanggal yung byproduct mo during polymerization. And an example of that is the polymerization to form polycarbonate. Kung saan tinatanggal ni pyridine or pyridine yung HCl. Okay, so actually yun lang yung step growth. And because of kulang na tayo sa time, hindi natin matatapos yung chain growth. Teka nga. Ano nga? Stop share. Ayan, since hindi natin matatapos yung chain growth, will it be okay for us to meet on Tuesday? So basically sa Tuesday, wala na kayong asynchronous for the next topics, but magkakaroon tayo ng synchronous discussion for chain growth. So diretso na tayo synchronous for next meeting, ay next set of topics. Will it be okay? Okay. Okay, may nagtanong dito. Actually, good question. Ma'am, sa solution polymerization, polycondensation lang ba siya, no? Yes, good job. Okay, yes, oo. Kasi, yun yung purpose ng solvent. To get rid of those byproducts. So, okay, did I answer your question? Okay, so see you on Tuesday to discuss chain growth. And if we have time, kasi madami din mga chain growth, yung mga techniques. If we have time, we can proceed with the next set of topics. And I can assure you sa next set of topics, madali na lang siya kasi it's a combination of step growth and chain growth. So okay, so see you and have a good Thursday. So bye-bye, everyone.
Thank you, Mom.
Sure.